Looking at question 1, this question is about an electric circuit. A particular filament lamp is rated at 12 volts and 6 milliamps. It just lights when the potential difference across the filament is 6 volts. A student sets up an electric current to measure the IV characteristics of the filament lamp. In the circuit shown below, the student has connected the voltmeter and the ammeter in the circuit incorrectly. The battery has an EMF of 12 volts and negligible internal resistance. The ammeter has negligible resistance and the resistor of the voltmeter is 100 kilo ohms. The maximum resistance of the variable resistor is 15 ohms. So all of that information you have been provided. So the first question is explain without doing any calculations whether there is a position of the slider S in which the lamp will be lit. Well, we know when it comes through here, so if I just take my current it's coming through, it can divide. It can divide between either going this way or that way. Now, depending where your current is, we usually use current from positive to negative, but I'm going to take it from negative to positive, thinking of the electrons here. So let's say you've got the electrons coming along there. They can either divide this way or that way. Now, because you've got this voltmeter with 100 kilo ohms, that's 100,000 ohms, and this is only 15 ohms, you're going to get very little current. A tiny fraction of the current is actually going to go through this path over here, through the light bulb. And so the vast majority of the current is going to go through your 15 ohms. So depending, it doesn't matter where you slide it. So if you slide it right the way across, so if you have your slider right the way there, where it has to go fully through that resistor before where that choice, even though it's a full 15 ohms, because this 100 ohms is so great, you're going to get just about zero current through. Also, from a point of potential difference, your potential difference across these two components, your potential difference across the voltmeter and across your lamp, those will add up to the total potential difference across this whole section. Now, because your V is equal to I times R, whatever the current, because this is so much greater than that, the vast majority of any potential difference in this section will be over the 100 kilo ohms, and so therefore the lamp will not be lit. Well, I hope you can write that down. If you need any further help on that, please come and see me. Now, estimate the maximum reading of the ammeter. So the maximum reading is going to basically be that we are going to view this just as a one resistor circuit. We can ignore this. Let me just get rid of this. That we ignore this, that because of the 100 kilo ohms basically switches off that part of the circuit. So you've got 15 ohms here, you've got 12 volts, so your I is equal to V over R. So it's going to be 12 divided by 15 ohms using that formula over there, and we get for that 0.8 amps. Then it says complete the circuit below showing the correct position of the voltmeter and the ammeter in order to determine the IV characteristics of the filament lamp. So basically what was wrong in the previous one was your position of your ammeter and voltmeter. So you've got your variable resistor there like that. We wanted that you are going to have your current going through the filament lamp so your ammeter needs to be in the part of the circuit where it's going through the filament lamp. This comes down like that, and then you need your voltmeter across in parallel with your filament lamp. So you'd have something like that, and this would be your 12 volts and so forth. Okay,